So 3 to the negative first is this 1 divided by 3. So 3 to the negative first is 1 over 3 to the positive first, or just 1/3. So that's a really important thing to pay attention to. Negative exponents move if they're in the numerator to the denominator or vice versa, denominator to numerator. So the exponent moves and becomes positive. So it was in the numerator, now it's in the denominator, and the exponent's positive. So this one's going to be 1 over to the positive second power, right, 3 squared, which is 1 over 9. We're just dividing by 3 each time, right? So this is proving to you why negative exponents work the way they do. So this one's 1 over 3 cubed, which is 1 over 27. Yeah?
Is it always 1 over?
Unless there was a number already in the top, yes. So anything to the 0 power is 1, proves that. And then the negative exponents, if it's negative in the numerator, they move to the denominator and become positive. Really important for you to realize. We'll probably have to come back to the slide 4 or 5 times because people didn't pay attention. Or you just need to see it to understand it. Okay, so not a big deal. We will come back to it a number of times, but just so you know. Anyone need more time with that stuff? You good? Okay. All right, break these two down. 216 to the 1/3 power, and 7 to the 1/2, 7 to the 1/2. 216 to the 1/3 power. We're going to switch from exponential, meaning it has an exponent here, to radical form. So the denominator of the fraction goes in the elbow of the square root. I remember that because this little part of the square root, in this case cube root, points down, right? So the denominator's in the elbow because the elbow points down. So denominator's down, the 3 goes in the elbow because that little check mark part of it points to the bottom. Now we're going to do cube root of 216 in your graphing calculator. So again at math, number 4, 216, enter. And it should work out like that. So math number 4, 216. Yeah. You're always scared, but you're always skeptic. All good. Okay, we good on that? Let's say I want to take 5th root. The way you take the 5th root, let's do the 5th root of negative 32. We'll do that a little later. So hit 5, hit math, then hit number 5, the X root button. And then you can put in negative 32 and enter, you get negative 2. Okay? So if you need to take the 6th, 7th, 8th root, you just type in 8, hit math, number 5 for the X root button, so on. You can also take, let's say we had, let's say we did negative 32 to the 2/5 power. What should that be? You should be able to tell me what the answer is. Higher level thinking question. To the 2/5 power. 4. Who said 4? You're correct. So negative 32 to the, and then I'm going to put 2 divided by 5 in parentheses like that. On my calculator, I don't have to, but actually this is going to be negative 4 because I forgot the parentheses, so let me put those in. So parentheses there. I don't know why I made it so gigantic. And parentheses there. Positive 4. Okay? So you can put in fractional exponents as well. Sometimes I'll make you break them down to the point where it doesn't even matter if you do this. You can just double check your answer. But I'll have you going from exponent to radical form and back and forth like that. All right. So 216, cube root of 216 is 6. And when I have the same base as I do here, I can add the exponents. So 1/2 plus 1/2 is 1. So 7 to the first power is just 7. So the 7's the base, the 1 is the exponent. The exponent tells you how many times to multiply the base by itself. I was tend to go too fast 7th period, so I'm always looking around. Same base is what matters, yeah. Okay? Write this one. So we're going to do this one 2 different ways. We're going to do it exponentially first and then do it radically after. So we're going to leave everything as an exponent. I want to try to get the same base. So I look at my base of 5. 125 is 5 to what power? 5 to the third. So I'm going to rewrite this like 5 to the 1/4 times 5 to the third, right? That's the same as the 125. And then I still have that 1/4 outside. I'm just trying to make this base be the same, right? So 5 cubed is 125, so that's where that came from. The first place where I lose people, so I appreciate the questions, it's good. So 5 to the 1/4 plus 3/4 is just 5. 5 to the first or 5. Okay, so no big deal on that. So I could give you this direction 2 different ways on a test or a quiz and make you do this problem 2 different ways. I could say solve this exponentially, and you'd have to go through this process. So if you need to write that down so you get the difference between the two, that's probably not a bad idea. So that's solved it exponentially, and this is radical form. So we can do the 4th root of 5 times the 4th root of 125. So when you've got the exact same, in this case 4th root, it could be square root, they could both be cube root. When I have the same index number, that's what that 4 is called, index, you can multiply what's underneath. 5 times 125 is, you can do that, come on. 5 times 125. 625. 4th root is 625. Right? 4, math, number 5. 625, enter. That'll give you 5. So 2 totally different ways to solve the same problem, both of them correct. So when we have the same radical, same index in the radical, you can multiply what's underneath and then take whatever the root is, in this case 4th root 625. Again, go ahead. Because you have to know everything I teach you. This is the kind of stuff where it's the exponent rules that are one of the tricky parts of calculus and pre-calculus as a result. So you got to learn all these rules and have them down cold by the time you get to calculus, otherwise you get destroyed, which is fun. Okay, so I forgot to erase this one. So we're just going from exponential to radical form here. So write those 2 down as x to the 3/7 power. I'll write it bigger so you can actually see. That's one of them, and then y to the negative 3.5 power. So does the 7 go in the elbow or underneath? Elbow. Right? I could write, this means the exact same thing. I could use 7th root of x cubed. Right? Depends on the problem, which one's the best. But those I would accept either as correct answers. Most people write it like this until they have to write it like that. What's 3.5 as a fraction? You can do 3.5, math enter, enter. That's what Shane doing right now, right? And what'd you get? 7/2. Okay? So this thing first becomes 1 over y to the 3.5 power, which becomes 1 over y to the 7/2 power. Negative exponents have to move first, and then you can rewrite it radically. So this equals 1 over the square root of y to the 7th. So nobody ever writes that 2 in a square root, but it's technically the second root. So this means the same thing as this. Okay, if you didn't know that, now you do. You learned it if you were in my class freshman year, you may have forgotten it, but you did learn it. Okay, so that's just a little sidelight, these two being the same thing. You could just write those down. I don't need it, I mean, whatever. Radical to exponential, you have to go both ways. Again, I'm just emphasizing square root and second root mean the same thing. Anyone need more? We have a couple people still writing. Good on that? Okay. So write that these down. So if you need a bigger, 4th root of x cubed over the 8th root of x squared. So a little reminder on the rules. If I have x to the 4th over x squared, what do I do with those exponents? Subtract them. So this becomes x to the 4 minus 2, or just x squared. We're going to do the same thing on this one, rewrite exponential and then subtract the exponents. So the numerator equals x to the what? 4/3 or 3/4? 3/4. This is x to the what? 8/2 or 2/8? 2/8, which reduces to 1/4. Okay? Then this equals x to the 3/4 minus 1/4, which equals x to the 2/4, which is the same thing as x to the what? 1/2, which is the same thing as, good. So smart when you try. I do, because you are, and you're doing very well. Okay? So x to the 1/2, the same thing as square root, right? I could have rewritten that like this, just square root of x. Or that's a lambda, in case you wanted to know. Yeah. No, either way is fine. Okay, we're going to do A and B on this page. Okay, write down A and B. So it's 1/2 plus what? This one is 3 to what power? 1/4. So we're going to add the 1/4. I can't add those fractions because they do not have a common denominator. What do I have to multiply that first fraction by? 2/2. So So I'm going to multiply that first fraction by 2 over 2. So we get 3 to the 2/4 plus 1/4, which is 3 to the 3/4 power. So now they say simplest form, but it's not entirely clear when that ends. I know there's math I can do in here with the 3/4. I can speak. So we can rewrite this as the 4th root of 3 cubed, and we can rewrite that as the 4th root of 27. And then the 4th root of 27 is not a whole number, it doesn't break apart at all, so we're done. Andre, question? You're soaking it in, aren't you? We got 2 more, I think. No, I lied. I take it back. So the numerator is x to the what power? Nope. Nope. When there's not, yeah, good. 3/2. Right? When there's nothing in the little index, put a 2 there. So it's 3/2 minus what? 3/2 or 2/3? 2/3 right here. So now to get a common denominator, you got to multiply the first fraction by 3 over 3, the second fraction by 2 over 2. Right, then we have common denominator of 6. So 9/6 minus 4/6. Which equals x to the 5/6 power. So if I say I want the final answer in exponential form, that's good. If I say I want the final answer in radical form, you'd rewrite it like that, 6 root of x to the 5th.
So if you just put that, if you write it in exponential, but we just use it like that.
Like this, you lose points because you don't know the difference. That's why I have to justify taking points off, and I'd like you to all advocate with that. That makes me even happier. You will not make that mistake. Yes, I can, because I'd say, which one is it? And you'd be like, I don't know. That's fine. And like circle the correct answer. I just have to know you know the difference, right? That's all. You're smart. You're not going to be asked like that. But you actually probably would. I take it back. You probably would. Okay, write this one down. Write that one down. There you go. Write it down, buddy. No. So this becomes 1 over 16 to the positive 2.5 power. What's 2.5 as a fraction? 5 seconds, good. So 1 over 16 to the 5/2 power, 5 seconds power. Yeah. Didn't be confused. 1 over square root of 16. We're going to put the 5 outside. Why did I put the 5 outside? It doesn't belong. Square root of 16 you can do evenly, so do that if you can. That's hard because I don't want to raise 16 to the 5th power because you get this obnoxiously large number. Right? I don't want to deal with that. So instead of that, I'm just going to take square root of 16, which is 4. So 1 over 4 to the 5th power. And everybody knows 4 to the 5th power is 1,024, right? I know. It's just off the tip of your tongue. So 1 over 1,024. So simplest form, this is the simplest form. If you leave it here, you lose a half point. Finish it, you get all the points. Okay? No. No, we gotta do this nastiest one with you. We're gonna do this one. He likes to cry a little bit, it's okay. Did you? What'd you cry for? Oh, you're just fully free? Hey, write that SOB down. What's happening? Yep. Look at them. It's a whole new crew. 7th period Algebra 2 is the way it should be. 7th period Algebra 1 should never be a thing. Freshmen should not take a 7th period. They should just like go prance in the field. Come on, children. Go prance. Okay. Yeah. So here's the issue with this problem. I'm going to rewrite it Gigantor style so you can see it. So here's the problem. We need to take this 2/3 and distribute to everything except this radical is like a root that's in the way. So this square root of xy means the same thing as xy to the 1/2 power. Yep.
Why are you distributing it to the x?
So it's all separate parts. The -8's one part, the x is one part, this x is one part, that y is one part. So there are 2 x's you got to deal with. It's annoying. Okay, so this, now we're going to distribute the 1/2 in. So I have x to the 1/2, y to the 1/2. So I just took this little piece over here, x to the 1/2, y to the 1/2. So now we're going to rewrite that. So now we're going to distribute all 4 parts. Enjoy. Where do I come from? You got to use your words now. Yep. Because we couldn't distribute because it was like in the way, right? So now that it's 1/2, we can multiply it. Because I couldn't distribute the 2/3. The root was blocking it. You have to. Let me finish, then I'll take questions, because I might answer some of your questions, and if not, then I'll come back to them. Go ahead.
What is a real life application of this? Like, what would you use this for?
Do you want to pass my class?
No, I'm just wondering.
Do you want to pass your class? Then shut up. Will you ever use this? I could give you some equation where you've got like cube root, 3/5 power, like sure. But you would look at that problem and go, I'm never going to do that. And I go, you're probably right. So we get nowhere, right? Yeah.
Where does the 1/2 come from? You distribute to xy.
Right here?
Yeah. Oh. No, like the first 1/2.
Yeah.
Up top.
This one?
That 1/2.
Square root.
2/1. Oh, it's 2/1. Okay.
Because of that. Okay?
Okay, sweet.
Does that help your understanding to put that? Yeah. Oh yeah, we're like halfway through. That's all. What's 2/3 times 1/2? 2/3 times 1/2 is 2/6 or 1/3. Exactly. Okay? So we're almost done now. One more simplification to get there. So the cube root of negative 8 squared is what this first part becomes. So cube root of negative 8 squared, like that. That equals 4. You can put that in your calculator, don't give me that look. So what do I get here with the x's? X to what power? X to the first, right? 1/3 and 2/3 is 3/3, which is just 1. And then y to the 1/3. Good job, you got it right. That's the final answer. Okay. All right, that's it. We're spending another day on this tomorrow, so you know. So don't freak out. Or you can. You can always freak out. 36.